So I just need to introduce a couple more useful methods when working with data that's in dictionaries. There are three methods to be familiar with: .items, .keys, and .values. So if I have a dictionary that looks like this, my dictionary equals, and then it's some key and value pairs separated by commas. And they might be name, Harry, hair, brown, eyes, brown. And then what I need to do is I need to get everything in the dictionary. I can use .items. So my dictionary.items will return all the key and value pairs, which I can then print or convert to a list or do whatever with. If I just want the keys or just want the values, I can use .keys and .values. And we make quite wide use of this. If you have a dictionary that contains a bunch of gene names as keys and a bunch of gene expression values as values, you might use .keys to get a gene list, and you might use .values when you're calculating the average expression or something. So rather than having to go through the list, go through the dictionary and use a for loop and get all the keys out of the dictionary, you can just use .keys and it will give you a big list of all the keys, or .values to get a big list of all the values. So yeah, .keys and .values are useful when we need to iterate over a dictionary and do something for every key or for every value. Okay, so here's an example of that. If I have the same dictionary I just defined, what I can do is for key in my dictionary, print the key and then the value that coincides with that key. So we've seen lots of code like this before. The only extra thing I'm introducing here is this comma in the print statement, which will mean that I want to print these things on the same line. So what this will do is it will get the first key from the dictionary, print that key, and the value associated with that key on the same line. If you put an extra comma at the end of the line, it's actually going to print all of them on the same line. And once again, if you want to make your code work with all versions of Python, I encourage you to put brackets around your anything you're printing after the print statement. Okay, so one of the coolest features of Python that saves coders a lot of time, but also takes a little bit of thinking to get your head around, is list comprehension. If you ask computer nerds why they like Python, list comprehension might be one of the reasons. It lets you do something that is takes a few lines of code in other languages in a much more simple way. So a lot of what we do in Python and what people do in computational biology in general is take some input list, do something to it, and create a new output list from that input that might be scaled values of, from an experiment or something. And list comprehension gives us an easy way of doing that. So let's say I have a list and it's range 10. Remember that range 10 is going to give us all the numbers from 0 to 10. And let's say I want to calculate the square values of all those numbers and store that in a new output list. Well, this is the sort of traditional, old-fashioned way you might do that. You would define an empty list of squares ready to fill with values, and then you would do for x in range 10, so for x in my input list, let's append x squared onto the end of that input list. So it's a pretty simple for loop that will go through getting each value from our input list, squaring it, and saving it in the, on the end of the output list. So this is the sort of basic way of doing this. List comprehension gives us a better way of doing this, because as you see here, we've had a for loop that goes through things, and you know, it's quite a lot of code just to achieve something basic. So in Python, what you can do is you can define a list within the actual square brackets of the list. You can do the looping over the input list all within the list definition. So this code and this bottom code do the same thing and achieve the same results. It's just the bottom one does it with less code and more elegantly. So what this means is that I want to define a new list called squares, and in it I want to have x squared for x in range 10. Now, a lot of this looks the same as what we had up here, for x in range 10, so for x in our input list. We have all of that here, for x in range 10. And the difference is we now put the x squared that we did in our append statement straight here before the for loop definition. So we want x squared for x in range 10. And that will take our input list, square every value, and save it in a new output list, all in one line, without having to write a separate for loop. So the general syntax is some expression for values in old list. So that expression could be a bunch of different things, and we can build up some fairly complicated statements in terms of list comprehension. So here's how we might achieve the reverse complement code we wrote before, but using list comprehension to save even more lines of code. Remember, we went from an if and elif nest with a bunch of lines to a dictionary definition that was even smaller, but we still had to loop over our input list. Well, here's how you might do it in just a few lines of code, and so little code that we can do it straight into the interactive environment. So we still need to define our complement dictionary, where the key A corresponds with the value T, and the key T corresponds with the value A. I'm then going to define my input sequence to be some sequence of letters. This is the value that I'm going to take the reverse complement of. And then the main body of the code that used to do for nuke in seek, check if it's a valid nucleotide, blah, 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 is all reduced onto this single line here. And what this line does is it looks up the value in the complement dictionary that corresponds with the key x for every x in our input list. So there's some extra stuff at the end, but you can just think of it as looking up every value corresponding with the key for x in seek. So the last stuff at the end, all that does is convert seek into uppercase, just in case, and only does it if x is in ACGT. So you see we've got quite a lot going on here, but the most of it is pretty self-explanatory. So it's going to look up the value corresponding with the key x for x in our sequence. Even if you don't include anything after this word seek, it will work fine. So the extra stuff is just to make it more robust. We're going to convert it to uppercase in case the seek is lowercase, and we're only going to do it if x is in ACGT. So this is list comprehension. We've defined an output list called revcomp using our input list and done it for every element in our input list. And the value that we're putting in our output list is the value associated with the key in the dictionary. And then the output looks like this. So this is almost there. The output is the complement, but it's not the reverse complement yet. And it's also a list rather than a string. So we started with this text, this string, and the output right now is a list of letters in square brackets, each separated by a comma. So there's 2 more lines of code to make the output nice and pretty, and as we might expect. The first one is .reverse, and that will do, as you might expect, it will reverse the list. So now we've gone from the forward complement to the reverse complement by calling .reverse on our list. The alternative way of doing that is to do something with the indexes of the list. You could have done from the beginning to the end with a step size of -1. And that's a shortcut to get the list in reverse order. But .reverse is very clear what it does and just as fast. Okay, so the final line looks a little strange because we have this empty quote, these bunny ears, but it's going to use the join method to push our string together from our list. So we have a list of letters that is successfully our reverse complement, but we don't want a list of letters. What we want is a string output where everything looks like a string like the input did. So for our nucleotides, that would take us from this list into a string like this, where everything is separated by nothing, by no string. Okay, so then now we have the result, which is our reverse complement of our input sequence. And we've used list comprehension, and we've used our dictionary. The final two lines are just tricks to reverse it and join it together from a list into a string.